I just finished grading. Now I'm going to do the tutorial. I'm so tired, so I'm going to sit down and do the tutorial on the exam, right? Next time I'll probably do it on the board, but this time I just have to do it while sitting down. Exam number 2. I have the ruler, I have the protractor with me, I have the pencil, and I also have the calculator. Okay, so the first problem, let's measure this vector. This vector is 3.8 centimeter. So 3.8 centimeter. You're gonna have to multiply it by 10 meters, so 38 meters. This vector is 4.2 centimeter, 42 meter. I'm gonna connect from this dot to this dot, and the name of this physical quantity is displacement. I'm gonna call it displacement. And how many centimeter is this? This is 5.6 centimeter, which is 56 meters. Now I can verify it by using Pythagorean theorem. If you want, you can verify it. Let's see what we get. (38 square plus 42 square is 56. So the math also gives us the same thing. Okay, now we're going to take the protractor. This is my 0, 0. I'm going to place it over here, and it is on my x-axis, so I exactly did 50 degree. Okay, now let's see whether the math is going to give us the same thing. To do that, I'm going to use SOHCAHTOA. So tangent theta is equal to opposite, which is this is the angle I'm trying to find. This is the angle 50 degree, my measurement tells me. So opposite is 42 and Jason is 38. So theta is tangent inverse 42 over 38. So I'm going to come over here, second, tangent 42 divided by 38, and that's going to give me 48. So this is the trigonometry give me 48, so plus minus 2, which is 50. Okay, great. So that's problem number 1. Problem number 2. What is the approximate diameter of a basketball? Now this is by itself is 1 centimeter. 1 centimeter times 2, which is 2 centimeters. This is 10 centimeter. 10 centimeter times 2, this is 20 centimeters. This is 1 times 2, 2 meter. This is 10 times 2, 20 meter. I have never seen basketball whose diameter is 20. I have never seen a basketball whose diameter is 2 meters. 2 centimeters is going to be too small, so it's 20 centimeter, which is 2. Okay, now problem number 3. The slope of displacement versus time, that must be velocity. I see speed. Okay, so I eliminate the first one. So the answer 1 can no longer be right because it has one wrong option. So answer 1 cannot be right. Okay, we done with this one. Slope of the velocity versus time, which is acceleration. Everything is right. Let's move to the next one. Slope of distance versus time. Distance versus time is speed. Oh, number one again. Wow, it's wrong twice. Oh, it doesn't matter. It doesn't have to be wrong twice. As long as it's wrong once, you can eliminate it. The area under the velocity versus time graph, that's displacement. Oh, okay. Cross out 2. Now we have a 50-50 chances. Okay. The area under velocity versus time graph, which is displacement, so we cross that. The area under speed versus time graph. Area under speed versus time graph is distance. So, okay, this is also wrong twice. Okay. The area under acceleration versus time graph, which is final velocity. This is not final velocity. Okay. So number 4 is wrong. Number 1 is wrong twice. Number 2 is wrong twice. Number 3, no. So it has to be number 3 then. Okay, great. So let's move to number 4. Find the uncertainty 400. Okay, so I'm gonna get some paper. Hopefully, let me get some paper. So 400. So first we're gonna write the sig fig for 400. I mean 4 times 10 raised to 2. Well, we don't have to. Yeah, maybe 400 is 4 times 10 raised to 2. So sig fig is 1. Uh, uh, we also can, well, let's do this way. We don't have to do that. 400, the last reliable number is 4. And 4 is, this is 1, this is 10, this is 100. So 100 divided by 2, which is 50. So 400 plus minus 50. Okay, that's number 1. Number 2, we're going to do 400 decimal. Okay, then what is the last reliable number? Last reliable number is then 1. So 1 divided by 2, which is 0.5. So 400 plus minus 0.5. That takes us number 3, 400 dot to 0. So now this is 10th. So the nearest 10th is 0.1. 0.1 divided by 2 is 0.05. So 0.05. So 400.0 plus minus 0.05. Okay, so our 1 is plus minus 50. Plus minus 50. Our 2 is 0.5. Our 3 is 0.05. 0.05. So 1 must be correct. Okay, so who is SI unit represent a derived physical quantity? So this is length. This is not derived. This is meter second. Okay, there is no physical quantity that is meter second. Meter is a length, which is distance. Second is time. Velocity is distance over time. Velocity is not distance time. So no, there is no physical quantity that is distance and distance time, because velocity is not distance time. Velocity is distance displacement over time, and speed is distance over time. So there is no physical quantity. Meter square second cube, there is no physical quantity which is meter square second cube. No. This one is area second. All right. So there are lots of physical quantity. For example, hydrology. So there are lots of physical quantity whose SI unit is meter square second. Meter square is area. So you find the area by the ruler, so that would be L times T. Okay. Number 2. Okay, now that takes us number 6 to 8. Okay, now this one, lots of people did this one. That would be 15. So lots of people did like this: 15 VF plus BI over 2. So 15 plus 0 over 2, 7.5. This, you cannot use this formula because acceleration is not constant. Acceleration is 2.5. Acceleration is 2.5 from 0 to 6 seconds. How? Acceleration is VF minus VI over delta t. VF is 15 minus 0 over 6. So 15 over 6. 15 divided by 6 is 2.5. Acceleration is 2.5 here and acceleration is 0 over here. So acceleration is not constant. When acceleration is not constant, you cannot use VF plus VI over 2. VF plus VI over 2 only works if acceleration is constant. I have to find the equations from 0 to 6. Find the equation of this one. There are many ways you can find it, but I'm going to use the easiest one. VF is equal to VI plus AT. I show you the other one before, but I'm not going to show you other one now. Plus A, you're going to write T minus T whatever, TF. Now, at whatever time, I don't know, at when the time is 0, velocity is 0. That's the easiest, I think. Plus acceleration is 2.5, so 2.5 t minus 0. So VF is equal to 2.5 t. That's very easy. V of t is equal to 2.5 t. And that's going to give you the that's going to give you the velocity at any point. For example, velocity at 6 or velocity at 4. Velocity at 4 is 10. Let's say velocity at 4 is 10. So this is 5 over 2, and then at 4 is supposed to be 10. It gives you 10. So you can check your formula many different way. Equation. Okay, that takes us number 8. Number 8, you always can, if you want, you can make it longer. So I ask you to, from, I know this point, so 0 comma 6 is accelerate. So you can write this point, 6 comma BH. So what is half BH? Half BH is, half B is 6 and H is 15. So 45, 6 comma 45. From 6 to 10 second is moving with constant velocity. So here is 10. So this is 10 comma. All right. So I have here 45, right? So here this triangle is 45 and this rectangle is BH. B is 4, H is 15. So this is 60. 60 plus 45, 105. Okay. So you can write 105 over here and you can write 10 over here. Okay. You can write 6 over here and you can write 45 over here. Okay, good. Let's move to problem number 9. Let's get a little bit more paper. Okay, so problem number 9 is very easy. D is equal to VAT plus half AT squared. We did few labs and you know that you can move to the x direction quickly, right? But if I ask you to move to the y direction, x direction you can move quickly, but y direction, if I ask you to move to the y direction, you can't, because acceleration due to gravity is -10, which you discovered in the class. So that's why I ask you this one, and the y direction, of course. So dy is how much? I give you 80, so it's -80 half ay has a name g, which is -10 t squared. So -80 is equal to -5t squared. So both sides you divide by -5, so t squared is equal to 16, so t is equal to 4, so this is 4 seconds. All right, so now let's do problem number 10. Problem 10, let's see. Problem 10, we're gonna do it here. Let's move it over there, so make sure you see problem 10, right? So problem 10. Problem 10. So I have 2000, number 1. So 2 times 10 raised to 3, and 2 is less than 3.16. So order of magnitude is 3. All right. So 3, 3, 3, 3. Oh, everything is 3. Go to the next one. 4000. 4 times 10 raised to 3. 4 is bigger than 3.16. So 3 plus 1, 4. 4, this is not 4. So 2 is bad. This is 4, this is 4. Okay, we can eliminate 2. 2 is, we can eliminate 2. Number 3, 8000. 8 times 10 raised to 3. 8 is bigger than 3.16. So 3 plus 1, which is 4. So 4, 4, 4. Okay, then we have to go to the next one. 4.0002. 2 times 10 raised to -4. 2 is less than 3.16. So this is -4. This is not -4. So we can eliminate 1. This is not -4. This is -4. Let's do number last one anyway. 0.0009. So 9 times 10 raised to -4. 9 is bigger than 3.16. So -4 plus 1. So -3. Great. So it turned out to be 4. Let's try to finish it quickly because I have to go home and it's already 11 o'clock. So this is so 5 at 5, so at 5 second, the velocity is 40 meter per second. So 5 comma at 5 second, what is the distance? Distance over here is -5, and distance over here is b, half bh. So half b is how much? 4. H is 40. So this is 280, right? That's the total distance. But this is, oh, you can always make it longer. So total distance is 80, by the way. Okay, total distance is 80. So how can you show that? -5 to 75 is 80. Okay. At 5, this is 75. Okay. At 1, this is 5. So make sure you have that. So the vertex is 1 comma -5. That is vertex. Okay. So this is the graph. I should put something below. Okay, let's go to the next one. Okay, whose car is accelerating? Of course, this car moving with constant velocity. This car moving with acceleration. So acceleration is probably 80/3. Okay, that's not what I asked you to do. I asked you to find how much distance it moved from 1.5 second. Okay, so how can you do that? Area is equal to half BH. Area is the displacement, half B is 3/2, and H is 40. So 2 goes to 20, 2 goes to 20 tens, 10 times 3, 30. 30 meters. Okay, let's do this one. This one, acceleration is constant. Why acceleration is constant? Because this is from 0 to 4.5, acceleration is constant. Acceleration constant. So you can use Vf plus Vi over 2. That is velocity. So Vf is at 4.5 is 6. Vi is 0 over 2. So this is 3. Okay, let's now come to the graph. Fix it a little bit because this is the copier messed it up. Okay. All right. So we have 8 sections. So this is 2, this is 4, this is 6, 8, 10, 12, 14, 16. This is 2, 4, 6, 8, 10. No, 2, 4, 6, 8, 10, 12, 14, and 16, so on. And I have the time over here. This is section 1, section 2, section 3, section 4, section 5, section 6, section 7, section 8. Section 1, section 2, section 3, section 4, section 5, 6, 7, 8. Section 1, the object moves 1 meter. I'm going to use this one, 1 meter. Section 2, object moves 0 meter. Section 3, object moves from 5, from 1 to 5, so 4. 5 to 6, 1. From 6 to 2, so -4. From 2 to 1, -1, 0, -1. Okay, so now 1 divided by 2, that's half. So this is half. The slope of this one is 0. Okay, now the slope of this one is this is acceleration is positive over here, so this is a positive diagonal line. So I have 4. So I'm going to show you what I mean. So I have 4. Let's write it. A is equal to half BH. So 4 is equal to half, and then you see it. Four, 4 is equal to half, 2, and velocity. So this 2 to cancel, so this is 4. So I'm going to go all the way over here. I'm going to connect it to the 4. The next one, I have 1. So I'm going to write 1 is equal to half, 2, velocity. Okay, so 2 to cancel. So then I have to move down to 1. Okay, all the way to 1. And velocity over here is 0. So I'm going to connect it. Okay, the next one, -4, right, is equal to half to velocity. So 2 to cancel is -4. So velocity, final velocity is -4, right? Okay, the next one is -1. -1 is equal to half to, and then velocity final. So this 2 to cancel, so I'm going to go to all the way to the -1. And velocity over here is 0, so I'm going to connect it. Okay, the slope of this one is 0. -1 divided by 2 is -half. So I'm going to shade it now. So this is, I'm going to be shading it. So this is 1, this is 0, this is 4, this is 1, this is -4, this is -1, this is 0, this is -1. Okay, I'm going to take the slope of this now. To take the slope of this, the slope of this one is 0. The slope of this one is 0. The slope of this one, VF minus VI over delta t, which is 2. VF is 4. 4 minus 0, 4 divided by 2, which is 2. So I'm going to go all the way to the 2. That's the acceleration. Here, I'm going to write VF, which is 0. 0 minus, this is 1. 0 minus 1 divided by 2, which is negative half. I'm going to come over here. VF is negative 4. So negative 4 minus 0 divided by 2, which is negative 2. So this is going to go all the way to the negative 2. Okay. For this one, VF, what is VF? 0 minus, this is minus 1 over 2. So this is positive half. The slope of this one is 0. Slope of this one is 0. We are done with this. Okay. Now average speed. Okay. So 1 plus 0 plus 4 plus 1, which is 6. 6 plus 4 is 10. 10 plus 1 is 11 plus 1 is 12. 12 divided by the total trip is 16. So 0.75 meter per second. Section 5, the acceleration is negative 2 meter per second squared. Section 4, the velocity equation. Section 4, the velocity equation. So section 4, you're going to write VF is equal to VI plus AT, T minus TF. Okay, now if I write over here, VF is equal to VI, let's say VI is, okay, at what second? 8 second VI is 0, right? So I'm going to copy it again, T minus TF. At 8 second, velocity is 0. And acceleration of this one, and this is section 4, acceleration of section 4 is negative half. So negative half, T minus 8. All right, so this is VF. So VF is equal to negative half T plus 4. So I'm going to write negative half T plus 4. Okay, now finally I'm going to do section 5. I'm going to go do this one. I need 2 points. This is 8 comma 6. That's vertex. And this is 10 comma 2. So X and Y. So what I'm going to do, I'm going to write y is equal to a x minus h squared plus k. So y is 2, x is 10, minus h is 8, plus k is 6. So 2 is equal to 4a plus 6. So 4a is equal to minus 4. A is equal to minus 1. So now what are you going to do? Y is equal to a x minus h squared plus k. Y is equal to minus 1 x minus h is 8 square plus 6. So y is equal to minus 1 x square minus 16x plus 64 plus 6. Distribute negative, minus x square plus 16x minus 64 plus 6. So y is equal to minus x square plus 16x minus 58. So you're going to write minus t squared plus 16t minus 58. We just finished creating the tutorial, and if you do see any mistake, then let me know. I already finished grading. I'll see you Tuesday. Bye.